Hello, everyone. Thanks for joining us today. My name is Krista Tweed, and I'm an applications engineer with HBK based in Madison, Wisconsin. I specialize in the Genesis high-speed product line and high-speed data acquisition. So our agenda for today is to let you know what's new with our power analyzer and how with the latest software release, the capabilities have been expanded for automotive electric motor testing. So I'll start with a brief review of our power analyzer. I'm not sure how many of you know it well, and then review the different improvements that have been made. I'm sure all of you are aware of kind of the landscape of measurements that happen in an electric drivetrain, but just to kind of get us all speaking the same language, of course, in a dyno test cell for an electric drivetrain, you typically have a power source, an inverter, an electric machine, and the test engineer is going to be interested in knowing the voltage and current out of that power source, the voltage and current from the inverter, the torque and machine output from the electric machine, possibly some other physical signals such as temperatures from the power source and inverter, as well as temperatures at the electric machine, and maybe some other physical quantities, things like vibration or noise or power or flow or pressure coming from that electric machine. And the eDrive power analyzer from HBK is able to bring in all of those types of signals and measure those together in a single mainframe in a synchronized way. The mainframe has an Ethernet connection out to the control room, where the test engineer is able to view live information coming from the system and make sure the test is running as expected. And we can also provide real-time calculated results over either CAN bus, EtherCAT, or through the GenDAC API out to the automation system running the test. So if we look into that integration system or integration capabilities a little bit more, on the power analyzer, we're able to provide a 1 millisecond latency of those real-time calculated results that get published. And depending on which bus you're communicating over, you can have up to 2,000 samples per second update rate coming out of the analyzer to the automation interface or to the automation system. Over CAN bus, you can have two-way communication, so real handshaking between of commands going to and from both the power analyzer and the automation system. And we are able to provide those real-time calculated results over CAN 2.0 or CAN FD. Same capabilities are possible over the EtherCAT bus, having remote control and two-way communication, as well as the published data. And the same is true for our GenDAC API system, our capabilities. We have a LabVIEW remote control that's in development, but will be released soon. That will be a cost option for the system. And then you can also have that same communication via Python. We're also always looking towards additional field buses and communication methods that make sense for the applications where our power analyzer is used. So let's look at some of these new features in Perception 8.5. Before Perception 8.5, the field bus output, that publishing of data, was available when the system was either in preview mode or recording mode. By preview mode, it just means the system is providing the user with live updates in our perception software, as well as publishing data out onto the field bus. And then recording mode would be when we're actually recording data. So writing data to a file and saving that raw information as well as the calculated result. When the system was in pause mode, meaning you're making a recording and you pause the recording so we're no longer writing that data to disk, the field bus output stopped. In addition, that recording file was always one file for every acquisition, and that file wasn't released by Perception until the recording was complete. And if those recording files got very large, you could divide the file up into multiple smaller files only based on the formatting of the system, of the file format, the disk where the data is being saved. So meaning if the formatting of that disk required no files larger than 8 GB, then at 8 GB, we would break that file up into multiple lower files, smaller files, and all of them had to be present to open that recording. What we've updated to now is to really be able to provide that publishing data continuously always. So no matter what the power analyzer is doing, whether we're recording data, we're in pause mode, we're just in preview mode, we're able to provide that published real-time output to the automation system continuously. So now when the system moves, but when the power analyzer moves between a pause and a resume, we go from recording data to saying, I don't want to save my raw data anymore, but I still want to see what's going on live. That's not going to have any effect on the field bus publishing. We also give the user a lot more flexibility for creating smaller files automatically with those recordings. We seem to have more and more users that are interested in, as soon as that raw data is saved, they're interested in grabbing it and running some scripts, doing some automated analysis with a third-party package. And so they want to have access to that data as quickly as possible. So you now have a lot more options in the preferences dialog in Perception to say, I want to split that recording into sub-recordings after a certain amount of time, or I want every sweep saved in a unique file so that I can immediately grab that sweep data and work with it. We also give the user the option to immediately start the system in pause mode. So as you boot up the system, it can load its user settings, run headless in your test cell, and we immediately go into pause mode. And that really puts you in a position where you're immediately getting field bus output information, but you also are able to immediately start a recording and get that recorded data as well. So that's a nice startup option. On the CAN bus side, we have an integrated, what we call the integrated CAN bus option for our tethered mainframes. And previously, that CAN bus supported 3 different, I say, features. So you could record CAN bus data. There are 4 CAN ports as part of the option. Each port can handle 250 channels that can be recorded and saved, that information saved along with your analog data. We also could publish data onto the CAN bus, so take the real-time calculated results that are being done in the hardware based on the analog channels being recorded by the mainframe and publish those to the CAN bus up to 240 signals at an update rate of 1,000 times a second. And then the third piece of the CAN bus capability was control. So being able to have that two-way communication between the power analyzer and the automation system to really have complete integration into the test cell. What's new with this release is that the CAN bus signals are now supported in what we call our real-time formula database. The real-time formula database is DSPs in the mainframe that do the real-time calculations, and you can now do those real-time calculations on the CAN bus data. So data that we have coming into the power analyzer from the CAN bus can now have calculations performed on it. You can look for those channels to be out of a certain range, for example. You can do additional calculations if you want to combine torque and speed that's coming in on the CAN bus with other information. You can do that. You can also then republish those results out onto CAN bus or another field bus. And our real-time formula database also supports generating triggers. So you can have calculations that watch for a channel to be outside a certain range or a channel to go above a certain level and generate a trigger so that then you're recording data when that event occurs. For example, maybe a temperature. You're interested in knowing if the temperature goes outside of a given range that you're expecting, and then you can have data start recording at that point. We've also extended the acquisition status information that is shared from the mainframe to the automation system. This is going to give the automation system a lot more information, detailed information, rather than just I'm in pause mode, or I'm idle, or I'm recording. It can really see I'm recording and waiting for a trigger, or I'm recording in continuous mode, much more detailed information to improve that communication between the two systems. We also changed from relative addressing to absolute addressing. So let me kind of explain. By relative addressing, what that meant, our mainframes have modules and they're configured by the user to meet their requirements. So let's say I have a 7-slot mainframe and I have modules in slots 1, 2, and 3, and then I have my CAN bus recorders. So the addressing was based on the fact that there were 3 recorders, modules, in the mainframe, and then I had my CAN bus. What that meant by using that relative addressing was that if another module was added to the mainframe, so they expand their system, they need to do more power measurements, or if a module was removed from the mainframe, that then changed the CAN bus addressing for those recorded CAN channels. And that could be a hassle and also inconvenient for the user. So what we've done now is add in absolute addressing. So the range 1 to 127 is always used for the physical recorders, the modules in the mainframe. And then 128 to 255 is used for the CAN recorders, no matter what number of modules are in the mainframe. For current users, that does mean they will need to do a one-time adjustment of their setup as they upgrade to 8.5 to adapt those addressing for the CAN recorders to be in an acceptable range. But once that's done, it's going to make their configuration much more stable, make it much easier to adjust the configuration of their mainframe without affecting the CAN bus. Our system is very good at recording a lot of data very quickly, and so our file sizes tend to get very large. When you're working with the data in perception, that's not a problem because the software was designed to work with that amount of data. You're not going to realize how big those files are. But if you're interested in moving that data outside of perception, you need to be very cognizant of the amount of data that you're exporting and make decisions on what you really need. So we've always given users a variety of options when they're going to export data, as far as the time window within the recording. Do you want the complete recording, between cursors, only what's in the zoom window, only what's in the alt zoom window, or maybe just a single triggered sweep? And channels to export. And in the past, you always needed to have the channels you wanted to export displayed together, either in a display or in a specific pane, so that you could select which channels you wanted. We've simplified that now. There's a new entry called Custom Channel Selection. You can click that 3 buttons, bring up a data source dialog, and you just select the channels that you want to export. And then you're able very easily to export only the channels of interest at the sample rate that you're interested in. We also added an artificial gearbox as a connector within the ePower Suite sheet. So whenever you have a gearbox included, it's often the case where you're not able, for a variety of reasons, to make torque and speed measurements on both sides of the gearbox. That might be due to space limitations or available channels on your data acquisition system. But when you measure only one of the shafts, it's often useful to still have some information about the torque and speed on the other side of the shaft. So we've added this mechanical gearbox connector that can be added into the Perception ePower configuration, and you're able to tell it at which location you're measuring torque and speed, enter the speed ratio between the two sides, and any information about known losses. And that way you'll have torque and speed information for the non-measured side of the gearbox available within perception. Let's look at some more general minor improvements, not necessarily new features, but kind of improving what was already there. We had feedback from a lot of users regarding stabilizing our live display. So we're able to provide live information to users while they're recording data or just while they're in pause mode. And those waveforms are often running, moving across the page. And people were interested in having more like an oscilloscope type display where it would just be stable on the display. So you now have the option in a live window. If you click on the hamburger menu, you can choose cycle triggered. And that will then trigger on a specific start to the cycle for whatever cycle source is defined currently in the system. And this does work best when you have one cycle source present in the setup. We have a harmonic analysis function that provides grid-based harmonic analysis on 50, 60 hertz type signals that meets the IEC 61000-4 standard. And we just added some more capability for the user to configure the harmonic display that displays the output of that function, where you can choose what start order and how many orders you want displayed in the harmonic display, and also use your own user values for the y-axis rather than having only be automatically scaled. Some improvements to general perception. It's now much easier to both delete a component in perception. Each component has an X in the upper right-hand corner that you can just click instead of having to right-click and go through several menu levels to delete a component. We also have added the ability to temporarily maximize one component. And I personally think this is pretty slick. So in perception, if you've got a sheet with several different areas and you say, I want to see a little more closely what's going on in that display, then I can click the maximize button. Now that display expands to fill the entire sheet, and then I can just restore it back to its normal place when I'm done. We also added the option in displays so that if you have a large number of signals all in the same pane, in the past you would have upper and lower limits listed for every signal in that pane. And if it was a lot of signals, 9 or 10, then this y-axis could get pretty messy. So we had the request from a user, actually several users, to say, can we just clean that up where you're only showing me the limits on the y-axis for my selected trace. So there is an option in the display properties dialog under annotation and grid to only show annotation for the selected trace. So then you're able to click between your signals and see the correct scaling for that trace. In the ePower suite, it is now possible to invert the timer counter channels in hardware. We previously had an option where we could do that through the real-time formula database, provide the option, say, yep, I want to invert the torque signal. We all know positive, negative torque is kind of arbitrary. It's just how that sensor gets installed in your drivetrain, and often then what's been defined by the engineers as far as what they want. You just need to flip the torque and make it positive instead of negative, or vice versa. And we did that through the real-time formula database before, but with this software update, we've now made that a hardware option for timer counter channels. So you have an invert signal checkbox in both torque and speed setup within ePower, and that gives you the capability to invert that signal in hardware, just flip it so that your result changes sign. We've also added the measuring time to be much more prominent on the ePower. Previously, you needed to go into the perception settings sheet to find that measuring time, but it's a really important parameter, and I think it's important for users to be able to see it and know what it is and make a conscious decision as to how they're setting it. So the way a timer counter channel works when measuring torque, for example, You can see the particular sensor I was using here was a 60 kilohertz torque sensor. That means when I'm at zero torque, that sensor is outputting a 60 kilohertz square wave. At maximum negative torque, it's maximum positive torque, it's 90 kilohertz, and at maximum negative torque, it's 30 kilohertz. So the way the timer counter channel functions is we measure that pulse train for the measuring time, in this case 500 microseconds. We calculate the frequency, and then we convert that frequency into torque based on that linear relationship. The measuring time is important for two reasons. One, it determines the accuracy of your measurement. As you can see in the graph down here, that depending on your signal frequency and the different measuring times, that's going to set the accuracy of that torque measurement for that timer counter channel. In addition, the measuring time determines how dynamic your torque result is. So after every measuring time, I will have a new torque value update. So the longer I make the measurement time, the more accurate my measurement is, but the less dynamic. It's going to be a longer amount of time before I get a new torque result. And so the test engineer needs to be aware of that and make sure that that measuring time is where they want it based on the accuracy and what information they're trying to get out of the test. We're also now able within ePower to show the meter values in review. So these meters in the perception software are designed for real-time feedback for the user to show you those real-time values. So that means when you open after your recording is finished and you're browsing around in the recording and looking at your data, you no longer get results from those meters. What they've done now is say it would be helpful to still get information in that. And so they've updated the meters so that when the recording is finished, you can move your cursor to a point of interest. And all of these meters are going to show you the values from these other calculated channels at that point in time in the recording. So that's a nice way to be able to get easily a little more parameter values out of perception. All right. I got to get back to my PowerPoint here. There we go. We added 3 new formulas into the real-time formula database around efficiency measurements. So there's an efficiency mode, efficiency value, and power loss. The reason for this was for the system to be able to provide one efficiency number to the user, and then the user also understand what mode. Is my power flowing from input to output or output to input? So it simplifies that. You can have one result that can get published to the automation system, also have the information on whether your system is running, motoring, or generating, and be able to have one value that you review rather than having multiple variables that then you think about and pull from that the information about the mode in which it's operating. I think this addition is really nice. Perception has 2 different ways to do calculations. So the main way they happen in the Power Analyzer is through our real-time formula database. That's happening in hardware in real time, and those results become part of your recording file. But we also have a post-process formula database. And there's always been a button in the ePower control panel called Review Formulas that you can click, and Perception will automatically recreate all the formulas in the real-time formula database into the post-process formula database. You say, now, why would I want to do that? The reason is really because we record that raw data. That means if something goes goofy in your test, or you just say, I wonder if I had done these calculations over a full rotation of the motor rather than over a single cycle of the current, how much does that change my power values? what analysis comes out of that that's a little bit different. And by having the formulas in post-process, you don't have to redo a test completely. You can just take that raw data, adjust your formulas the way that you want them adjusted, and then you get new results. And so that's a powerful feature. Also, when you run into problems in your test. I had one customer call me a few months ago and say, I'm getting really wacky power values and I don't understand what's going on. And we dug into it a little bit, and it turned out they were testing a new prototype motor. And when the prototype had been built, the output of the motor, the phases had been mislabeled. So I2 was actually I3 and I3 was actually I2. And so then they could take these post-processed formulas, just flip the raw data between those two current phases, and now they have results for that prototype motor without rerunning that test. In the past, you always had to have your hardware connected to be able to create those review formulas, and now that's no longer the case. You can now open up a saved PNRF recording file, click that, and the review formulas will be created based on the information in the virtual workbench. There's also been a hardware improvement on the bandwidth of our power modules. So for GN310B, 311B, 610B, and 611B, those are all of our cards that are typically used to measure power. 2 new filters have been added through the firmware change that you can have both a Bessel filter and a Butterworth filter analog only that expand the bandwidth of those modules. So now, starting with 8.50, when you look at the filter list of options available to apply to the channels, you have 2 new entries on those channels. So in summary, Perception 8.50 provides expanded integration capabilities to the eDrive Power Analyzer, and also, as of all of our new software releases, adds some experience improvements and bug fixes in there as well. The maintenance on your Perception license must be good through August 1st of 2023 to upgrade up to Perception 8.50. So summary, HBK's eDrive Power Analyzer gives you future-proof testing capabilities. You can measure up to 51 power channels in a single mainframe, up to 6 torque and speed channels. Not only can you record your electrical and torque and speed, but you can do other mechanical signals as well, all with a single piece of hardware. You've got the feedback to the automation or hardware in the loop systems. And if you're doing hardware in the loop testing, you can have a single software that you use for both the hardware in the loop and then your physical testing. Our power analyzer provides accurate and dynamic power results with good power accuracy across a wide variety of frequencies and voltage ranges, and provides accelerated testing because we're doing real-time cycle detect. Our system, you don't have to wait for our system to stabilize. You're going to be able to get very dynamic power results out of that system. You're able to treat HBK as a one-stop shop, get torque sensors, current sensors, power meter, everything together. We're also happy to provide worldwide training and support to get you up and running with your system and make sure it's working well for you. Our system also provides auditable tests, so we are recording that raw data, giving you a lot of capability to really look into and understand what's going on with the system. You're always going to see the equations that we're using for our calculations, and you can create your own as well. And you've got lots of flexibility to see live data as well as do advanced analysis and perception. If you're interested in more information, you can go to hbm.com/eDrive and find data sheets and product overviews. Our worldwide technical support contacts are in North America and outside of North America are listed there. So now I'll turn it back over to Stuart, and we'd be happy to answer any questions.